Now let us consider another problem as per which there is a discrete time signal given as h of n is equal to 1 comma 1 where the first one corresponds to instant n is equal to 0. If Fourier transform of h of n is given as h of e power j omega, then find the expression for phase of h of e power j omega for every omega. We know that the DTFT of h of n is given as sigma n h of n multiplied by e power minus j omega n, which is equal to 1 plus e power minus j omega. Hence the same can be simplified as 1 plus cos omega minus j times sin omega. So from this we can write the phase of h of e power j omega as minus tan inverse of sin omega divided by 1 plus cos omega. We know that sin omega is equal to 2 sin omega by 2 cos omega by 2, and 1 plus cos omega is 2 cos square omega by 2. So upon substituting these formulae and simplifying, we get phase of h of e power j omega as minus tan inverse of tan of omega by 2. So this is equal to minus omega by 2. From this we see that the phase of h of e power j omega is equal to minus omega by 2. Now let us consider another problem as per which there is a discrete time periodic signal given as x of n is equal to sigma n I is equal to minus infinity to plus infinity delta of n minus 4i. It means that the given signal x of n is periodic with a period of 4. It is given that x of k is non-periodic and discrete. We have to say if this statement is true or not. We see that the given signal x of n is discrete and periodic. So from this we can say that the frequency representation of x of n is DFS, and by the nature of the DFS we know that DFS is discrete and periodic. From this we can say that the given statement is not correct. Now let us consider another problem as per which there is a signal x of t given as shown in the figure. X of t takes a value of 1 in the range of minus t by 2 to plus t by 2. Please note that x of t is continuous and non-periodic. We have to find the Fourier transform of x of t. We know that Fourier transform of x of t is given as integral minus infinity to plus infinity x of t multiplied by e power minus j omega t dt, which upon simplification becomes minus t by 2 to plus t by 2 e power minus j omega t dt. So this can be simplified as e power minus j omega t divided by minus j omega, and the direct limits are t by 2 and minus t by 2. So this upon simplification becomes e power j omega t by 2 minus e power j minus j omega t by 2 divided by j omega. But we know that sin x is equal to e power jx minus e power minus jx divided by 2j. Using this formula, we can write that Fourier transform of x of t is 2 times sine of omega t by 2 divided by omega. So we can see that for the given x of t, which is a pulse in the range of minus t by 2 to plus t by 2 with a magnitude of 1, the Fourier transform is given as 2 times sine of omega t by 2 divided by omega. Now let us consider another problem, as per which there is a continuous time periodic signal given as x of t is equal to cos of 1.2 pi t plus cos of 2 pi t plus cos of 2.8 pi t. We have to find the fundamental frequency of the signal in H. We see that the given signal x of t contains sinusoids at different frequencies. We see that the first sinusoid cos of 1.2 pi t is at an angular frequency of 1.2 pi radians per second. So that implies it is at a frequency of zero point 0.6 Hz. Similarly, cos 2 pi t is at an angular frequency of 2 pi. It means that it is at a frequency of 1 Hz. Similarly, cos 2.8 pi t is at an angular frequency of 2.8 pi radians per second. It means that it is at a frequency of 1.4 Hz. From above, we see that the given signal x of t contains the frequencies zero point 0.6 Hz, 1 Hz, and 1.4 Hz. So the fundamental frequency is written as greatest common divisor, that is GCD of above frequencies, which is zero point 0.2 Hz. So the fundamental frequency in the given sequence in the given x of t is zero point 0.2 Hz. Now let us consider another problem, as per which there is a discrete time signal x of n given, which has a dtft of x of e power j omega. Now there is another signal minus 1 whole power n x of n given. It is derived from x of n. We need to find the dtft of the same in terms of x of e power j omega. We know that Fourier transform of minus 1 whole power n x of n can be written as sigma n minus 1 whole power n x of n multiplied by e power minus j omega n. We know that minus 1 can be written as e power j pi. So minus 1 whole power n can be written as e power j pi n. So this is equal to sigma n x of n multiplied by e power minus j of omega minus pi times n. So this is equal to x of e power j times omega minus pi. From this we see that if x of e power j omega is the dtft of x of n, x of e power j times omega minus pi is the dtft of minus 1 whole power n x of n. Now let us consider another problem, as per which there is a signal there is a function f of t which is real. It has a Fourier transform of f of j omega. Now there is another function f of g of t given as f of t minus f of minus t. We need to comment on the Fourier transform of g of t. We see that f of t is real, so g of t is also real. If we find out g of minus t, this is equal to f of minus t minus f of t, which can be written as minus of f of t minus f of minus t. This is equal to minus g of t. From this we can say that g of t is odd as well. So here we see that g of t is real, g of t is odd. So g of t is conjugate skew symmetric. We know that If g of t is conjugate skew symmetric, Fourier transform of g of t, that is equal to g of j omega, is purely imaginary. So we can say that for the given derived signal g of t, the Fourier transform is purely imaginary. Now let us consider another problem as per which there is a signal x of t which has a Fourier transform of x of j omega. Now there is another signal y of t which is derived from x of t as d by dt of x of t minus dt. Now we need to find the Fourier transform of y of t, that is y of j omega, in terms of x of j omega. We know that Fourier transform of x of t minus td can be written as e power minus j omega td multiplied by x of j omega. Similarly, we can write that Fourier transform of d by dt of x of t minus td is equal to j omega multiplied by e power minus j omega td multiplied by x of j omega. So we see that for the given y of t, which is d by dt of x of t minus td, the Fourier transform is j omega multiplied by x of j omega multiplied by e power minus j omega gt. Now let us consider another problem as per which there is a continuous time non-periodic signal given, that is g of t. It has a continuous time Fourier transform of g of j omega as shown in the figure. It is in the range of minus 4 pi to plus 4 pi, and it has a value of 2 at omega equal to 0. Now we have to find the energy of the signal g of t. We can say that g of j omega, sorry, the energy of the signal g of t can be written as integral minus infinity to plus infinity mod of g of t whole square dt is equal to 1 by 2 pi integral minus infinity to plus infinity mod of g of j omega whole square d omega. So this can further be simplified as 2 times 1 by 2 pi integral 0 to infinity mod of g of j omega whole square d omega. This is because g of j omega is even. So we can write that g of j omega is a straight line joining 0 comma 2 and 4 pi comma 0. So from this we can write that g of j omega is equal to minus 2 pi into omega plus 2. So here we see that at omega equal to 0, g of j omega is 2, and sorry, minus 1 by 2 pi, yes. So at omega equal to 0, g of j omega is 2, and at omega equal to 4 pi, g of j omega is equal to 0. So upon substituting, we get that energy of g of t is 1 by pi integral 0 to infinity 2 minus omega by 2 pi whole square d omega. This is equal to 1 by pi integral 0 to infinity 4 plus omega square divided by 4 pi square minus 2 omega by pi d omega. Sorry, please note that the limits are from 0 to 4 pi. So this can further be simplified as 1 by pi 4 omega plus omega cube by 12 pi square minus omega square by pi 4 pi to 0. So this can further be simplified as 1 by pi 4 into 4 pi plus 64 pi cube divided by 12 pi square minus 16 pi square divided by pi. So this can further be simplified as 16 plus 64 by 12, which is 16 divided by 3 minus 16. So this is equal to 16 by 3 joules. So by using the Parseval's theorem and the Fourier transform of g of t, that is g of j omega, we could deduce that the energy of the signal is 16 by 3 joules. Now let us consider another problem as per which there is a signal y of t which is derived from another signal x of t minus 2 divided by 3. Now here x of t has a Fourier transform of x of j omega and y of t has a Fourier transform of y of j omega. Now obtained y of j omega in terms of x of j omega. We know that Fourier transform of y of t is equal to y of j omega is equal to integral minus infinity to plus infinity y of t e power minus j omega to t dt. Upon substituting y of t as x of t minus 2 divided by 3, we get y of j omega as shown. Substitute t minus 2 divided by 3 is equal to e. From this we get that dt is equal to 3 times dp. So from this we can get y of j omega as 3 times integral minus infinity to plus infinity x of t multiplied by e power minus j omega multiplied by 3p plus 2 dp. From above, we can write that y of j omega is equal to 3 times e power minus j2 omega multiplied by integral minus infinity to plus infinity x of p multiplied by e power minus j omega e power minus jp multiplied by 3 omega dp. This can further be simplified as 3 times e power minus j2 omega multiplied by x of j3 omega. So for the given relation of y of t is equal to x of t minus 2 divided by 3, we can write y of j omega as 3 into e power minus j2 omega multiplied by x of j3 omega. Now let us consider another problem as per which there is a signal, discrete time non-periodic signal given as x of n is equal to sine of omega cn divided by pi n. We have to find the energy of this signal. We know that the energy of the signal E is given as sigma n equal to minus infinity to plus infinity mod of x of n whole square. By Parseval's theorem, the same can be written as 1 by 2 pi integral minus infinity integral minus pi to plus pi mod of x of e power j omega whole square d omega, where x of e power j omega is Fourier transform of x of n. But for the given x of n, we know that the Fourier transform is given as 1 for mod omega less than or equal to mod omega less than or equal to omega c, 0 otherwise. From this We can simplify the right hand side of energy calculation as E is equal to 1 by 2 pi integral minus omega c2 plus omega c d omega, which upon simplification becomes omega c divided by pi. So by using the Fourier transform of x of n and the Parseval's theorem, we can obtain the energy of the signal as omega c divided by pi. Now let us consider another problem as per which there is a discrete time signal x of n given whose dtft is x of e power j omega. We know that the dtft of the given signal is as shown in the diagram. It is present in the range of minus pi to plus pi and it has a magnitude of 1 in the range of minus pi by 2 to plus pi by 2. Here we have to find the value of x of 0. We know that using the synthesis equation, x of n can be written as 1 by 2 pi integral minus pi to plus pi x of e power j omega multiplied by e power j omega n d omega, of which x of e power j omega is shown in the diagram. Upon substituting n is equal to 0, we get x of 0 is equal to 1 by 2 pi integral minus pi to pi x of e power j omega d omega. From this we see that x of 0 can be written as 1 by 2 pi times area of x of e power j omega with omega axis. So this is equal to 1 by 2 pi multiplied by area of x of e power j omega with omega axis. So first we write this area as sum of two areas. First we find the area of the region marked, which is equal to pi into 1 plus next we find the area of the region marked, which is half into pi by 2 into 2. This is mainly to consider the the triangles present on both sides. From this we can say that the area of the value of x of 0 is equal to 1 by 2 pi multiplied by 3 pi by 3 pi by 2. So which upon simplification becomes 3 by 4. So from this we can say that the value of x of 0 is 3 by 4. Now let us look into another problem as per which there is a continuous time non-periodic signal f of t and another signal g of t which is derived version of f of t. It's given that Fourier transform of f of t is f of j omega and Fourier transform of g of t is g of j omega. It's also given that at omega equal to 2 radians per second, abs of g of j omega is equal to 4 times abs of f of j omega, and at omega equal to 3 radians per second, abs of g of j omega is equal to 9 times abs of f of j omega. We need to find the possible relation between g of t and f of t. We know that if g of t is equal to d square f by dt square, then g of j omega is equal to j omega whole square multiplied by f of j omega. From this we can write that abs of g of j omega is equal to omega square multiplied by abs of f of j omega. Based on this we can see that the two given conditions would be satisfied for this relation between g of j omega and f of j omega. So the possible relation between f of t and g of t is g of t is equal to d square f by dt square. Now let us consider another problem in which it is given that there is a polynomial, there is a discrete time signal f of n which is expressed as a polynomial in n. It is given that this is of finite length and only contains odd powers of n. So based on this, we have to find out the value which is not possible for Fourier transform of f of n. The values are given in the options A, B, C, D, and D as 1 plus j, 2j, 3 cons. From this, we see that there is some data given as related to f of n. The data is that f of n is a polynomial in n. It is of finite length and it contains only odd powers of n. From this, we have to find the option which is not possible, which is not a possible value for Fourier transform of f of n. The options are given as shown. It's given that f of n contains only odd powers of n and is of finite length. From this, we can say that f of n is odd, and it is also given that f of n is a real polynomial. So, from this, we can say that f of n is conjugate skew symmetric. We know that if f of n is conjugate skew symmetric, then Fourier transform of f of n is purely imaginary. So, from this, we can say that option A and C are not the possible options, as the value in the option B is purely imaginary. The value in option B could be a value of Fourier transform of f of n. So the correct option is B. Now let us consider another problem, as per which there is a continuous time signal given as f of t is equal to sine cube of t plus cos square of t. We need to find the alternate Fourier series expansion of this signal. We know that for the given f of t, the period is 2 pi. This is because the period of sine cube of t is 2 pi and the period of cos square of t is pi. So the period of f of t is LCM of these two values. So from this, the period of f of t is 2 pi. So now we have to find the expansion of f of t in terms of sine of at, where a belongs to z, and cos of bt, where b belongs to z. So from this we can see that sine cube of t can be written as 3 by 4 sine t minus 1 by 4 sine cube t. This is because of the reason that 1 by 4 sine 3t. This is because of the reason that sine 3t is equal to 3 sine t minus 4 sine cube t. Similarly, we can write cos square of t as 1 plus cos 2t divided by 2. Upon substituting the values of sine cube of t and x square of t in f of t, we can get the Fourier series expansion of f of t. Upon substituting for sine cube of t and cos square of t in f of t, we get the alternate Fourier series expansion of f of t as f of t is equal to 1 by 2 plus 3 by 4 sine t plus 1 by 2 cos 2t minus 1 by 4 sin 3t. So this is the alternate Fourier series expansion of given f of t. Now let us consider another problem. As per this current problem, there are four options given. The option A is 2 cos t plus cos 3t. Option B is 2 cos pi t plus 7 cos t. Option C is 1 by 2 plus cos t. Option D is 2 cos of 3 pi by 2t plus cos of 7 pi by 2 by t. Out of the four options given, we have to find which of the options doesn't correspond to Fourier series expansion of a periodic signal. From this, we see that if we consider the option A, where the signal is 2 cos t plus cos 3t, 2 cos t is at an angular frequency of 1, cos 3t is at an angular frequency of 3. Here we see that omega 2 divided by omega 1 is equal to 3 by 1 is equal to 3 is rational. So this is a Fourier series expansion of a periodic signal. In case of option B, which is where the signal is given as 2 cos pi t plus 7 cos t. Here 2 cos pi t is at an angular frequency of pi radians per second and cos t is at an angular frequency of 1 radian per second. Here we see that omega 2 by omega 1 is equal to pi, and this is not rational. So this is not a Fourier series expansion. Similarly, if we consider option C, here the signal is given as 1 by 2 plus cos t, and we see that it is at an angular frequency of 1 radian per second. So this is a Fourier series expansion. If we consider option D, where the signal is given as 2 cos 3 pi by 2t plus cos 7 pi by 2t, we see that cos 3 pi by 2t is at an angular frequency of 3 pi by 2. Cos 7 pi by 2t is at an angular frequency of 7 pi by 2. From this we see that omega 2 divided by omega 1 is 7 by 3, and it is rational. So it is the Fourier series expansion of a periodic signal. From this we see that the signal in option B, that is 2 cos of pi t plus 7 cos of t, is not a Fourier series expansion of a periodic signal. Now let us consider another problem, as per which there is a signal given which is a continuous time signal and it is a periodic signal. It's given that the signal is of period 2t, and please note that the signal given is a square waveform. If we consider the alternate Fourier series expansion of f of t, find the power of n for which are the Fourier series coefficients are proportional to n power k, then find the value of k. So it's given that for the given signal x of t, in the alternate Fourier series expansion, the Fourier series coefficients are directly proportional to n power k, and here we need to find the value of k. Here, please note that it is given that the signal is of period 2t. From the given signal x of t, we see that x of t is odd. From this, we can say that a0 is equal to 0 and an is equal to 0. So we can get the so as a0 is equal to 0, the dc term is 0. As an is equal to 0, the cosine terms are absent. So from this we can say that bn is equal to 2 by t integral 0 to t x of t sine of omega nt dt. Here we know that omega n is equal to 2n pi divided by 2t, that is equal to n pi by t. Upon substitution, we get that Bn is equal to 2 by t integral 0 to t sine of n pi by capital T into t dt. On simplifying above integral, we get that Bn is directly proportional to 1 by n, but it is given that Bn is directly proportional to n power k, and we need to find the value of k. On comparing, we get that k is equal to -1. This is the required answer. Now let us consider another problem as per which there is a signal x of t given. Please note that here one period of x of t is given, and it is given that x of t is periodic with period t. X of t is a in one period of x of t is a pulse from minus t by 4 to plus t by 4, and here x of t is shown from minus t by 2 to plus t by 2. Remaining waveform is just an extension of this waveform. It's also given that the Fourier series expansion of x of t can be given as a0 plus sigma n equal to 1 to infinity an cos of n omega t plus bn sin of n omega t. Here we see that the given, here we have to find the terms that would be present in the Fourier series expansion of x of t. We see that the given signal x of t is odd. So from this, the DC term will, the given signal x of t is even. That so from this we can say that a0 is not equal to 0 and an is not equal to 0 and bn is equal to 0. This is because x of t is given. Also, due to the non-zero area of x of t in one period with time axis, we can definitely say that the DC term is equal to a0 is not equal to 0. Also, due to the half wave symmetry, we can show that in case of an, only the odd coefficients will be present, and even coefficients will not be present. From this, we can say that x of t will contain the terms a0 and an where n is odd. So x of t will not have the terms corresponding to an where n is even and bn. Now let us consider another problem as per which there is a signal which is continuous time given as x of t is equal to 1 plus sine of 50 pi t multiplied by cos of 30 pi t. We need to find the Fourier series expansion of x of t. We know that if x of t is Fourier series expansion, it should be a weighted sum of sinusoids. So from this we can say that x of t is equal to cos 30 pi t plus sine of 50 pi t multiplied by cos 30 pi t. We can simplify sin A cos B term as half multiplied by sine of A plus B plus sine of A minus B. So from this we can simplify x of t as cos of 30 pi t plus half multiplied by sine of 80 pi t plus sine of 20 pi t. So this expansion that we have just written looks like a weighted sum of sinusoids. From this we can say that whatever we obtained is the Fourier series expansion of x of t. Now let us consider another problem as per which there is a continuous time non-periodic signal f of t given and its second derivative, that is d square f by dt square, is given as shown. It is an impulse at the instant plus 1 and is of magnitude 1. It is another impulse at the instant minus 1 and that is also of magnitude 1. It also contains an impulse at the instant 2 equal to t equal to 0 and it is of magnitude minus 2. And this plot, whatever is shown, is of d square f by dt square. We need to find the Fourier transform of f of t. From the given plot, we can say that d square f by dt square can be written as delta of t minus 1 plus delta of t plus 1 minus 2 times delta of t. Upon taking the Fourier transform on both sides, we get that Fourier transform of t square f by dt square is equal to j omega whole square f of j omega equal to e power minus j omega plus e power j omega minus 2. This is because Fourier transform of d square f by dt square is equal to j omega whole square f of j omega and Fourier transform of delta of t minus 1 is equal to e power j minus j omega and Fourier transform of delta of t plus 1 is equal to e power j omega and Fourier transform of delta of t is equal to 1. From this, we can show that minus omega square f of j omega is equal to 2 cos omega minus 2, which upon simplifying becomes f of j omega is equal to 2 into 1 minus cos omega divided by omega square. So from the given d square f by dt square plot, we are able to get the Fourier transform of f of t, that is f of j omega, as 2 times 1 minus cos omega divided by omega square.